Hi everyone, my name is Tiffany Jin and I'm a mechanical engineer at Facebook. Together with Emily and YJ from Hive and Inspur, we're going to present today on the OAM Reference Systems. When we started OCP Accelerator Infrastructure, or OAI, we set up multiple chapters to have specifications and subgroups to develop them. You are probably already familiar with the OCP Accelerator module, or OAM specification, and you're also probably already familiar with the Universal Baseboard, or UBB specification. Several other specs have been released as well, which will be reviewed in other talks within the OAI track. We have also recently released a common tray specification, which uses a sheet metal tray with front panel, ejectors, and slide rails. This 3U tray, shown in the lower left here, is modular and can fit any universal baseboard, which in turn can fit any 8 OAMs. It is also flexible, allowing for multiple options of front panels should one decide to change or move the I/O. Inspur and Hive have each developed a full system with slightly different architectures to accommodate different use cases. They demonstrate that OAI can indeed be modular. Each of them uses 8 OAMs, a universal baseboard, and the same common tray. Note that, as such, common trays can be interchangeable between each of these OAM reference systems. Here's another look at these two OAM reference systems that we'll be discussing today. They share some features as discussed in the previous slide. These reference designs, presented by Inspur and Hive Design Solutions, show how different connection topologies and rack dimensions can be supported. Next, I will hand it off to Emily Yang, who will talk through Hive Design Solutions reference design.
Hello everyone, I'm Emily, Technical Program Manager from Hive Design Solutions. Today I'm going to walk through the Hive Design Solutions OAI system design. Hive OAI system is featured with dimension of 19-inch width, 5RU height and 30-inch in depth. 3RU is designed for the universal baseboard and 2RU is for the host interface board. It is a disaggregate system design from host, flexible to integrate into 21-inch open racks through a support shell. UBB is able to support multiple OAM modules. The interconnection topology is fully connected and 6-port hybrid Q mesh, allowing 8 OAM modules for intensive AI training workload. There are 8 QSFP-DD connectors supporting 28G NRZ or 56G PAM430 interface for the OAM scale-up, allowing the scalability across multiple OAI systems. There are 16 PCIe Gen 4 by 16 slots on the host interface board. 4 are used for the host connectivity. The remaining 12 can be used for PCIe expansion and also the flexible I/O. One USB 3.0 form factor debug port to support the OCP debug card for the BMC error message display. 1 gigabit RJ45 dedicated for the BMC management. 1 power button and also 1 UID button in the front. There are 8 80 by 80 mm dual rotor fans in the rear, able to support 8 OAMs up to the 450 watt cooling at 35 degrees C. Power delivery is the 54 volt input, which is from the rack bus bar through 2 power clips on the PDB. This is a system explore view. Hive OAI system implements modular stack design concept. The upper layer is UBB tray, and lower layer is the HIV tray. UBB is in common tray design, which means that able to support interchangeable fungibility between the 3 OAM reference systems. This page shows side view system stack-up. Middle plane links UBB and HIV. Behind the middle plane, there are PDB assembly with the busbar clips for the power delivery from rack busbar. This is system front view. You can see there are 8 QSFP DD connectors on the UBB. In the HIV side, there are up to 4 PCIe slots for upstream. The remaining PCIe slots are for flexible I/O, one RJ45 BMC dedicated LAN, and one USB 3.0 for the OCP debugger and also the UID and power button. This is the system real view. There are 8 fans in the rear side and two 54-volt busbar power clips in the middle. This is about PCIe topology. Hive OAI system is able to support flexible I/O configurations. There are 4 PCIe Gen 4 switches on HIV. Each switch supports 4 by 16 PCIe slots, so totally 16 slots on the HIV. In topology 1, 2 CPUs from host server. For OAI, PCIe slots are used for the PCIe signal input from host through the PCIe retimer cards installed in the host side and pass through bridge boards on the HIV side. The remaining 12 slots are used for the flexible I/O such as InfiniBand, NIC cards, or the NVMe flashes. In topology 2, bridge boards are populated in 2 out of the 4 PCIe upstream slots. 2 PCIe Gen 4 interconnection cables are used to connect switch 1 to switch 2 and also switch 3 to switch 4. 2 PCIe by 16 upstream signal from host. The remaining 10 slots are used as a flexible I/O for InfiniBands, NIC cards, and also the NVMe flashes. This is also the topology used for the BERT AI training workload like demo. Topology 3 is very similar to topology 1. The major difference is 4 PCIe by 16 root port from 4 host CPUs in this topology. However, only 2 CPUs in the topology 1. This shows host and OAI system connection. We use mini-SAS HD cables to connect host retimer cards to bridge boards inside the OAI system. 4 pairs of mini-SAS HD cables in topology 1 and topology 3. 2 pairs of the mini-SAS HD cables in topology 2. Topology 2 is the configuration used for the BERT AI training workload live demo. You can see the live demo result from the virtual OAI experience lab. This page is about BMC power on control design. Host BMC will send DC on command to OAI BMC for power on. Then keep polling checking if OAI power on until the OAI system power good signal is ready. Then after the OAI boot, host BMC will send command to power on host to sync the power on sequence between OAI and host, as well as getting the OAI healthy status from OAI BMC to host. Host BMC has IPMV channel added to communicate to OAI BMC. Regarding BMC secure boot, we use CPLD as root of trust on HIV for BMC secure boot. CPLD will verify BMC image integrity and authenticity. If image is good, which is a fresh 0, then BMC boot. If image is tainted, recover fresh 0 image with the backup fresh 1 and then continue the boot process. Regarding the validation and availability, we have successfully power on 8 OAMs under the OS level with single host to upstream PCIe Gen 3 by 16 and also the OCP Gen 3 host retimer class and bridge board. Our Phase 1 board and system level electrical, SI, and function validation already done. Phase 2 system can run the AI training workload BERT on the pedal framework successfully. We will move into a more comprehensive Phase 2 board and system validation, including the reliability. Target to complete all of the validation by Q2 this year. So this means that system to be available in Q3 if anyone wants the samples to test. Our productization goal is in Q4 2020, which is system hardware ready schedule. This is also require alliance with the OAM partners. Call to action, you can virtual visit Hive OAI system from the Hive virtual booth, or go through virtual OAI experience lab. The latest spec is also available in the OAI wiki, and welcome to mail us for any questions. Thank you.
Hello everyone, my name is YJ, the Development Manager in INSPIR. Today, I'm so glad to have this opportunity to introduce you a 21-inch OAI reference system from INSPIR, MX1. First of all, I thought that it will be more persuasive if there are some real sample or pictures before the introduction. So, here is the MX1. On the left of the slide is a 3OU OAI reference system. You can see that it's pretty simple. And looking to the right side is OAI reference system MX1 and our host ON5263M5. You can see that they are connected by a high-density whisper cable, which is up to 80 pairs differential signal, support PCIe Gen 4 by 32. For the detail of the host and OAI system, it will be discussed later. Let's back to OAI reference system first. Here is the outline of INSPIR OAI reference system MX1. Width is 537 mm, height is 141 mm, depth is 803 mm, fulfills a standard 21-inch OCP rack mount. From the front side, you can see that there are a front I/O connector for docking a cable with a USB port for UR debugging, and a RJ45 port for BMC dedicate, and the whisper cable connectors for host connecting. Totally 8 QSF PDD connects for OAM expansion, and up to 4 standard half-high, half-long PCIe by 16 expansion slots for NICA, SSD, etc. From the rear side, you can see that there are 4 9256 fans there, and the 48-volt busbar power clip. Okay, here is the detailed features of INSPIR OAI reference system MX1. As I said, INSPIR provides you a 21-inch OAI reference system, so the chassis is 21-inch rack mount, and because INSPIR is very aggressive, we want to provide you a high-density solution. The height is 3 open units only. The connection between OAI system and host is PCIe Gen 4 by 32. That is the reason we use a high-density cable and connect with 80 pairs differential signal for connection. About OAM, we support 2 kinds of OAM, 54 volt and 12 volt. If OAM is support OAI spec 1.1, it should be workable on the system from hardware point of view. And our power consumption without OAM is around 1600 watts. For the rest features, they are too detailed to be introduced here. I will show you our block diagram later. Here is our system explored view. Honestly, our design is simple and makes me have nothing to introduce here. Maybe just let you know that OAM will be screwed on UBB and UBB will be screwed on UBB command tray, and we can put the UBB command tray into the chassis. HIB and PDB could be installed from the real top side, and the side cover is designed for PCIe 8-on-car install. And the top cover, side cover, fan, PDB, UBB command tray are all toolless designed. Okay, as I said, I will show you the block diagram later. Now is the time. You can see that the connection between host and OAI system is PCIe by 32. And there are 4 PCIe Gen 4 switches on our HIB, up to 100 lanes for each switch. So for each switch, it connects to pair PCIe by 16 to OAM, and 1 pair PCIe by 16 to the host, and 1 pair PCIe by 16 to PCIe expansion slot, and 2 pairs PCIe by 16 to another 2 switches. There are total 96 lanes here, and we reserve 4 lanes for management. For the 8 OAMs, we have 8 PCIe retimers. Each one supports PCIe Gen 4 by 16. And for the QSF PDD, we used 4 PHY retimers. For each OAM, we have 8 SerDes lanes for expansion. So we can use only 4 PHY retimers, and each one can support 56 gigabit per second PAM4 or 28 gigabits per second NRZ by 16 to connect with another OAI system. Here is our system placement. I think after previous introduction, this page is just for your reference. Nothing special here. Okay, in this page, let me show you the UBB placement. And the items I list here are included in the UBB spec 1.0, including the PCB size and the connectors we choose. Surely for those connects, you can have your own source, but just make sure they are 100% compatible with the spec. And in the next page, I'd like to introduce Inspur's HIV Design to you. As we mentioned, the connects on UBB rear side are defined in UBB spec 1.0. If you want to dock the HIB with UBB, you need corresponding connects on HIB. That says, those connects on HIB are also divided too. And Inspur wants to provide you a thin and compact system. So we use the high-density connects and cable to connect host and PCIe expansion slot here. About the PCB size and other connects are just for your reference. Okay, we talk a lot of EE hardware-related feature. It's time to talk about mechanical and thermal-related topics. For the mechanical part, we have a lot of useful design, but I just want to highlight the label on UBB command tray here. In the previous page, we said that there are a lot of connects were defined on UBB rear side, which is used to dock with HIB. And because there are so many connects there, it's really hard to plug or unplug UBB from HIB. The mounting force is around 700 Newton, and the UBB command tray with OAM is around 20 kilogram. You can imagine that how hard to do the service on it. The label on UBB command tray is so important that it can make plugging or unplugging the tray much easier. I'm not kidding you. Every time our RD and I want to plug or unplug UBB from HIB without a label, we just feel that we are gonna die. So thanks to the mechanical RD design a label for us. For the thermal design, here is one thing that we want to highlight, and which is different with what we introduced in 2019 Regional Summit. We added the top cover and the module handle for OAM heatsink, which makes service easier. Consider the limitation of system outline. The fin area was reduced from 66.1 mm to 63.3 mm. And we also reduced the simulation for this change. It shows in following 2 pages. Here is the system placement and the setting of component power consumption. We can just take a glimpse here. And here is the simulation result. You can see that the temperatures are all in an okay situation here. And we are doing the real test in our lab now. The results should be ready pretty soon. Finish the introduction of OAI Reference System. Let's back to the host provided by INSPIR. About the host, ON5263M5. In the 48V 21-inch rack, we plan to have an OCP standard qubit chassis for it. And because the host is using 12V as an input, we are also going to have another PDB with 54V to 12V solution on it in the qubit. With the qubit chassis, now we can put everything into a rack. In the end of INSPIR OAI Reference System introduction, I'd like to propose our rack level solution. It's not an optimized one, but it could be a reference. We have a 100 GB TOR switch and a 1 GB management switch here, with 4 hosts and 4 OAI systems, and a 33 kW power shelf. The cable between switch and host are Ethernet cable. We use whisper cable between host and OAI system, and the QSF PDD cable between different OAI systems. Okay, that's all. It's INSPIR's introduction for OAI reference system. And so far, the power on system is ready. You can also see how it works in the Experience Lab online. If you are interested in this product, you can have a connection with OCP OAI JDA group via following website and email address. Thank you.
Okay, hi everyone. My name is Tiffany Jin. I am the Facebook representative, and I was the first speaker. I guess just to keep everyone in the loop, we don't actually have the representatives from INSPIR and Hive answering questions live today due to the time zone difference. But if you have any questions, you can feel free to ask in the chat or in the questions and answers tab, and I will do my best to answer. Or we can always chat after, or we can reach out to Emily or YJ. So the first question that we have is, are fan components pulling 54 volts or 12 volts? And I think that was a question about the Hive reference design. The Hive reference design is a 54 volt input coming in from the rack, and the fans are also using 54 volts. Although they're the UBB, the universal baseboard, is taking 12 volts. Like there's a power distribution board for the UBB. But to answer that question, the fan components are pulling 54. I think that is actually the only question that I see so far. I see that there's a lot of other people on the line, so feel free to ask questions as well. Otherwise, Archana has put a link for the OCP Experience Center, and we have a few additional videos showing some of the live demos, as well as some of the system overviews in the Experience Lab. Okay, seeing as there are not additional questions, I think we'll end a little early so that you can prepare for the next one. Once again, feel free to visit the Experience Lab. We'll have people answering questions there as well. Thank you.